Hi, firstly, I would like to introduce myself. I'm a PhD student at Tebessa University. My topic today will be about groundwater recharge estimation in semi-arid zone. A study case from the region of Tebessa, located in eastern Algeria. This work aims to assess the recharge for the water table in the region of the basin of Wadi Tebessa by hydrogeological approach to be done and to fill the lack of climatic data in the absence of meteorological measuring station on land. The Google Earth Engine platform was used to extract the values of the rainfall for 9 years from 2010 to 2018. This estimate was then compared to the volumes of water mobilized in the basin for the same period, and this in the absence of piezometric chronicle for the same period. This approach allowed to establish a preliminary assessment for the spatial distribution of groundwater recharge based essentially on the nature of the rock and rainfall. This study focuses on the Tebessa basin, which belongs geographically to the eastern end of the Saharan Atlas. Administratively, it belongs to the commune of Tebessa, located about 70 km southwest of the wilaya of Tebessa. The region is located in the topographic map of Tebessa and the map of Sharia, a part in the sheet of Bersbekiya map. The basin of Tebessa is an anticline of Atlantic direction, northeast-southwest. It's bounded to the north by the Babus syncline and the Sharia plain, to the south by the Raslash plateau, to the east by Eluted syncline, and to the west by the Tezembul Ford. The region is characterized by a semi-arid climate with a relatively cold and rainy winter and a very hot and dry summer. The basin of Tebessa, which is located in the south of the Tebessa district, is an anticline surrounded by the reliefs for the Jebel Bukemesh in the north, Jebel Krima in the northeast, Jebel Dbibir and Wasif in the south, and Jebel Aghur al-Kifan in the west. This basin, dominated by the tertiary and quaternary soils, was filled during this period by sediments of continental facies from the limestone massifs that border it. Indeed, the Wadi Tebessa and its tributaries, draining this basin from northeast to southwest, have deposited fill material such as alluvium-forming fluvial terraces. This geological context would allow the coexistence of two types of aquifers: superficial alluvial deposits, and deep tertiary formations underlying the alluvial deposits, which could have a hydraulic potential more favorable to exploitation. As the basin is located in the Atlantic domain, its structure is dominated by the vast Atlantic fold with a diaphragmatic core. This has caused several faults, giving rise to strong fracturing of the Cretaceous age formations, with would facilitate winter infiltration. For this study, the Google Earth Engine platform was used to extract precipitation data. Google Earth Engine facilitates a fast analysis by using Google's computer infrastructure. Processed monthly data of TerraClimate dataset of monthly climate and climatic water balance for global terrestrial surfaces was used to assess precipitation data across the study area. The spatial resolution are all equal to 0.25 degree by 0.25. In addition, geological maps were processed. Data on the production of existing boreholes in the region were exploited. The QGIS program was also used to implement the mapping work. 10 rainfall gauge stations were selected, which covered almost the entire of Telijan Basin. To achieve the research objectives, data processing methods were used, including GIS processing. Google Earth Engine based data processing and GOG observation using TSN polygon method. The first part is to download monthly precipitation in 2010 to 2018 TerraClimate and use GIS analysis functions to interpret data. Change coordinate system to the same area using the function zonal statistic as table in order to get the amount of precipitation with shapefile of boundary. The second part is to develop the JavaScript code in the Google Earth Engine platform. The code included importing the TerraClimate image dataset, specifying the boundary of the study area by uploading shapefile into Google Earth Engine data script, extracting the mean monthly precipitation of the basin by writing code on script. After having executed the code, the precipitation data were retrieved on subbasins automatically. Lastly, the aerial precipitation from GOG station were estimated by TSM polygon method. The groundwater recharge value was estimated using a hydrogeological model, which depends on soil and rock infiltration coefficient. In the table below, we give the methodology of calculation of groundwater recharge using infiltration coefficient. The result of variation of recharge using the hydrogeological model shown in the figure below The equation of this model was given by the equation as follows. Groundwater recharge is equal to the coefficient of infiltration multiplied by the precipitation divided by 100. Rahmani and al. Have uniformized the geological coefficient to derive a linear relationship multiplied by P, which is the precipitation, where the groundwater recharge is equal to 0.034 multiplied by the precipitation. The annual variation of precipitations and groundwater recharge estimated by the hydrogeological model is illustrated in the figure below. As we see, the annual mean rainfall approached 390 mm per year, which characterized the climate of the region. A high precipitation value was observed in the north of the region in 2011, and it varies from year to year, from the east to the west. We also see that the variation of groundwater recharge is between 1 and 45.41 mm per year. In the absence of terrestrial weather station in the Telegen Basin, the results of the rainfall extracted through the Google Earth Engine platform were useful to us to determine the recharge in the Telegen area. The average annual recharge is estimated for the Telegen area to be around 125 mm per year. This region is thus characterized by a moderate recharge. The graphical representation of the number of wells in operation as well as the global volume mobilized over 9 years shows a strong demand for water, which proves that this recharge does not allow an availability for resources. During the same period between 2010 and 2019, 3 boreholes were abandoned following a drop in productivity. The purpose of this work was to determine the value of the recharge from the rainfall data and the geological characteristic of the rocks. The use of data excreted from Google Earth Engine comes in the objective to fill the lack of measurements due to the absence of terrestrial measuring stations in the basin of Telegen and the absence of piezometric chronicles that could better characterize the phenomenon. The comparison of the recharge judged moderate according to the calculated model allows us to say that these inputs remain insufficient to meet local needs. Technical measures as well as a rigorous strategy must be put in place in order to quantify a rigorous follow-up of the hydraulic drillings exploiting the aquifer must be set up in order to better define the behavior of the aquifer of the region in relation to the surface impulses, in particular the meteoric recharge. Thank you for watching.